Hi friends, good evening. Today we are going to discuss another section of vector analysis, that is different operators used in vector analysis. So let us start with the first operator, that is gradient, right? What is gradient operator, right? So how we represent variation of a function with respect to a particular axis, right? For example, I have a function, right? So that is phi. So this phi variation along x-axis, that is dou phi by dou x, right? That means keeping y as a constant, z as a constant, because that quantity is not varying, right? Here I told you only one parameter is varying, the phi is varying with respect to x only, that is dou phi by dou x. Then how I represent the variation of phi, right? What is d phi? Change in phi, right? A small change in phi, how I find? So definitely I multiply with the dx, right? Then this and this cancel, this is the variation, alright? So now you consider a physical quantity varying according to x, y, z axis. That means a three-dimensional function, or I can say phi is a function of x, y, z, right? Phi is a function of x, y, z. Then for x-axis I am writing this, right? Dou v by dou x. Suppose I am finding the variation of v. V is a function, right? Then variation of a function, right, with respect to x-axis according to this relation. Now plus variation of the same function with respect to y-axis plus variation of function with respect to z-axis. This dv represent the variation of function v, alright. Now let us see how we can represent this. In vector form I can represent this as, right, see dv is equal to, I can write dou v by dou x I cap plus dou v by dou y j cap plus dou v by dou z z cap, alright. Dot this dx dy dz dx I cap plus dy j cap plus dz k cap, alright. Now you take the dot product, dou v by dou x dx, I dot I 1, dou v by dou y dy, j dot j 1, dou v by dou z dz, z cap, sorry this is k cap, alright, k cap dot k cap, that is equal to 1, alright. Then dou v by dou z dz. So definitely I can represent like this. Now I am extracting this particular thing, right? What is this? This is equal to this operator, this I can write as dou by dou x, dou v by dou x I cap plus dou v by dou x j cap plus dou v by dou z k cap. This notation, this is known as gradient of phi, right? Gradient of phi, or I can write gradient of phi, or this is function v, so I can write as gradient of v, alright, gradient of v, alright. Now where v is a function of x, y, z, v is a function of, or a function is phi, this is a function of x, y, z, here we used v, then v is a function of x, y, z, alright. Then what is this gradient v representing? Dou v by dou x I cap plus dou v by dou x j cap plus dou v by dou z k cap. Alright. Then let me think about an operator del. This alone, how we write it? That is equal to, can I write I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Now if you multiply this with v, then only this become this, right? That means this is an operator, I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Alright. So this operator representing to find the variation of a particular physical quantity in different direction, right? So that is the use of this particular operator, gradient, del, right? When you apply function to this, what we say, gradient of that particular function. Alright, this operator itself we call it as del, right? Now what is the physical significance of this? Let us go to that, right? Alright. So as we discussed, this is the gradient of the function, right? This is the gradient of the function v, right? Now what is this operator? This operator is called del. So if we apply the function v here, right, then only it is gradient, right? Now what is the gradient importance, right? See, this direction of the gradient is, suppose you have a surface, right? You have a surface, right? Then that surface is, what is the normal to this vector? This normal vector is along the gradient direction. Suppose this function is, suppose this is phi of xyz, right? This surface representing equation is phi of xyz. Then gradient phi direction, right? That is normal to this surface. That is very important. Gradient phi direction is normal to the surface. Then if a possible question asked like this, a surface equation is given, what is the unit normal vector along it? Then definitely you can find, suppose this is n cap, this is a vector del phi, right, gradient phi, alright, gradient phi is a vector, y cap, x cap, y cap, z cap is there, is a vector, alright. Then what is this unit vector n cap? That is gradient phi divided by its modulus, alright. Any unit vector is equal to that vector divided by its modulus. Here the normal vector is, it has the direction of gradient phi, right? The unit vector along that is that gradient phi divided by modulus gradient phi, alright, alright. So that is one equation, alright. Now another equation is, suppose two surfaces, right? Another possible question, let me show. Suppose two surfaces given, right? One surface is this, alright. Another surface is this, right? Okay. It is placed at an angle theta. Now, what is the angle between these surfaces? This equation of this particular phi 1 of xy. Equation of this is some phi 2 of xyz. We can write xyz, 3 dimension, x, y, z. This is given. equation of the two surfaces given, what is the angle between these two surfaces? Definitely, what is the normal to this surface? Normal to this surface has the direction of del phi 1, alright. What is the normal to this surface? Del phi 2, right. Then what is this angle should be equal to this angle. Then angle between, this is a vector, this is another vector. If two vectors given, what is the angle between that vectors? We already studied. What is that? Del phi 1, right. Cos theta is equal to del phi 1, right. Sorry, del phi 1 dot del phi 2, right, divided by, this modulus is not there, right, del phi 1 dot del phi 2 divided by mod del phi 1 mod del phi 2. This equation basically we studied angle between two vectors, right. So using that we can find angle between them, alright. So what is gradient phi? Gradient phi is representing the normal to the surface, the direction of normal to the surface, right. So you can find the unit normal vector angle between two surfaces, that all we can find from that, right. Also gradient phi has the meaning of maximum rate of change of a physical quantity. Suppose, look here, suppose a refrigerator you consider, right. Okay, let me consider one AC, right. So one AC you consider, right. So everywhere its cold air is spreading to all the space, right, into that particular room, right. So where you get a maximum, suppose one person here, one person here, one person here, right. So different position I located 3 person in a room, right, and you fixed your AC here. Now which is the direction normal to this surface of AC, right, this one, right. So this is del phi direction. This is not a del phi direction because it is coming with an angle theta, this also coming with an angle theta, alright. So this person getting maximum cool air, suppose this distance, this distance, this distance, right, x is equal to y is equal to z, alright. Then also maximum cool air getting for this person, why? This gradient phi representing normal to the surface, and also this direction gives the maximum rate of change of the physical quantity, right. So you taken a function phi, its maximum rate of change is happening normal to that surface, alright. That also one important thing you should know about this concept, alright. Alright. Now let us go to another operation, that is divergence, right. What is divergence, alright. So divergence we basically represent del dot A, right. We seen what is this del operator. What is del operator? I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, right. Now dot, suppose A is a function, A is a vector function, that is ax I cap plus ay j cap plus az k cap, alright. Then what is the dot product with A, right, ax, right, dou A by dou x, dou ax by dou x plus dou ay by dou y, dou ay by dou y plus dou az by dou z. Alright. So when you take dot product with a, that means this with this, then I dot I 1, j dot j 1, k dot k 1, then dou by dou x of x, dou by dou y of ay, dou by dou z of dz, right. Then this divergence is a scalar quantity you are getting, right, because in the final result we have no I cap, j cap, k cap, alright. That means it is a scalar, alright. Now what is the importance of divergence? When we studied basic section of vectors, we studied there what is the importance of dot product, right. This is del dot A. Wherever we discuss a diverging quantity, we take dot product. Wherever we discuss about a rotating quantity, there we take cross product. Reason also we discussed there, right. See, because of cos theta component, one particular quantity is diverging like this. Because of a perpendicular component, one quantity is rotating like this, For example, one common example for the divergence of electric field, right. In electrodynamics we will study later, but for the time being, you see what is the equation for a divergence of electric field. Differential form of Gauss's law you take, we studied del dot E is equal to rho by epsilon 0. What does it mean? Electric field is diverging. That means suppose you placed a point charge, the electric field is always diverging, right. Right. If charge density of this particular sphere is rho, that divergence of electric field is rho by epsilon 0. Alright. Now, whenever we discuss with electric field is diverging. Now, when we discuss about curl operation, we discuss about magnetic field. Why? Curl is cross product. That means their rotation, magnetic field is rotating and electric field is diverging. It is discussed during curl discussion, right? Alright. So, this is divergence of a function, alright. Divergence means it is representing the divergence of a physical quantity. Suppose at the center of a sphere is a three-dimensional figure. So, divergence of electric field not only in x-axis but also in y-axis, z-axis, every axis it will diverging in a three-dimensional charge distribution. So, we must need the divergence of electric field. This operator why we taking? Because for a three-dimensional figure, three-dimensionally charge distributed body, the electric field is diverging in 3 dimensions, alright. That's why we using dot product of a three-dimensional quantity, alright. Now, let us go to another operator, curl, right. What is curl? As I discussed, first we study how mathematically we find curl, right. Then curl is del cross A. Then let us come to physical significance. See, look here, del cross A. This is representing curl. That means del cross A representing rotation of that function A. Right. So, if A is equal to ax I cap plus ay j cap plus az k cap, how we find a curl? That is important. I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, right. We studied how we find A across B, coefficient of A vector in the second row and coefficient of b in the third row, right? So here del, right, this is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z cross this, right? Then coefficient of I, j, k first row, dou by dou x, dou by dou y, dou by dou z, that is second row, and ax, ay, az, that is third row. Alright. So this way we find cross product of two vectors, right? So del cross A we find a determinantic form like this. Alright. Now what is the physical significance? You can expand a determinant expansion also, you can do I cap into dou by dou y, dou az dou y minus dou by dou z of ay, right? This kind of expansion we can do, alright. So not required now. During problem time only we require determinant expansion, alright. Now what is the important what I told? That means rotation of a physical quantity. See, you take a current carrying conductor, right? Current carrying conductor, then magnetic field is rotating around it. See, magnetic field how rotating? If thumb indicate this is the current direction, thumb indicate the direction of current, then the curved fingers represent the direction of magnetic field. That means rotating like this, alright. That means what is you studied the one equation there, del cross B is equal to mu 0 j, right? That means the rotation of the magnetic field around a current carrying conductor, that is determined by mu 0 times current, right? Current density. So current density through this conductor is J, right? This is not J cap, this is current density vector, right? J. So this J vector that depends on that particular current, alright. So del cross some function representing the rotation of that particular function, alright. Now finally we can study some rules regarding gradient, divergence, curl, right? See, suppose you find a gradient of product of two function, right? One is phi, one is psi, right? Then as you know differentiation product rule, right? Like that you can find it, alright. How we find it? That means the first function into gradient of second function plus second function into gradient of first function, alright. Now divergence of a plus b is divergence of a plus divergence of b, alright. Now div of a scalar function into a vector function, alright. Then the scalar function you keep out and find the div of the vector function a, and then the vector function a you keep out, then the gradient of phi, second function, alright. So gradient of first function, keep second vector function out, alright. Now divergence of curl A is equal to 0. What does it mean? Divergence of a curl, suppose electric field, right? Electric field is diverging only, not rotating. Electric field is always diverging, right? Then it is not rotating. Then divergence of electric field, its rotation I take. What is that? What is that result I get? 0, because diverging quantity never rotated. Then divergence of a rotating quantity also 0. Now curl means rotating, curl of a diverging quantity also 0. This both result. Divergence of a rotating property also 0, and diverging quantities rotation also 0. Alright, so both result important. Divergence of curl A is equal to 0 and curl of gradient phi, that means del cross gradient phi, this is 0, and divergence of curl A, right, that means del cross A or del cross phi, whatever it is, right, this also equal to 0, right. Okay, now think that gradient defined for a scalar function, right, gradient defined for a scalar function, curl, a rotating function, is a vector function. That's why we symbolically used here arrow mark. Here no arrow mark means phi is a scalar function. Alright. So important. Alright. So now the finally div A cross B equal to B curl A minus A curl B. Right. So divergence of cross product of two vectors, that means second vector into curl of first vector minus first vector into curl of second vector, right. So these properties help you to solve the problems. This also you should by heart, right. So in the next class we will do some problems, right. Okay, thank you.